In this linear modeling problem, we have two sectors, and each of those sectors produces something. In one case, the goods sector produces some sort of material or uh, some sort of actual item, and the services obviously provide some sort of service. And what we do know is that the goods sells some of its goods to the services sector, keeps some of the goods, and similarly, services sells some of the services to the goods sector and retains some of those services. So the question we want to ask, or the easiest thing to start with here, is the constraints. We've got to be careful because the variables here aren't exactly totally clear. So the constraints are this last statement here. We want to find equilibrium prices for the annual outputs. Equilibrium prices. So I guess that's a good hint of what our variable is going to be for the annual outputs that make each sector's income match its expenditures. So our constraints are of the form, we want to make sure that each company's income equals their expenditure or expenditures. And we want to make sure that that's true for goods, and we want to make sure that's true for services. So we've got to define some variables now. Now, in this case, we are sort of given a hint as to what these are. Now, we can't say X is the number of units of that good sold, and Y is the number of units of service sold, like maybe one oil change, and maybe here it's one t-shirt. That doesn't make sense. You can't equate one t-shirt to one oil change because the value of that good may not equal a 1 unit value of that service. So the way we're going to define these is the annual output. So we'll call this the total goods output. And how are we going to quantify that? Well, it probably makes sense not to think about this again in terms of units, but in terms of the total goods output in dollars. So that if they produce, let's say, 100 shirts at 20 bucks a pop, then they basically produce $2,000 worth of goods. And similarly, we want to make sure that the total services output, which is measured again in dollars, because otherwise we can't form equations that involve X and Y if the units are not the same. We can't add apples and oranges and end up with bananas. So it makes sense that these should be the same units. And we're going to quantify the total goods in the dollar amount and the total services in the dollar amount. So now we can talk dollar to dollar, and that makes complete sense to do. So now we have to think about the total income. Well, the total income for the goods company is literally the total goods output, right? So however much I produce, that's how much my income is. That's how, or my potential income is X dollars worth of goods. But now I've got to take into account my expenditures, and I want to make sure that how much I make, the total good output in the dollar amount, is equal to how much I spend. Well, I'm spending by buying some of the services, and I'm buying 70% of the total services output. Okay, well, total services output is Y, and I'm buying 70% of Y, so my expenditures just for that are 0.7 times Y. But I have more expenditures because, unfortunately, I'm not selling all X dollars of goods. I'm keeping 20% of them, so I have to absorb that cost. If I produce $1,000 of goods, let's say X equals 1,000, well, yeah, that's my income because I can sell that. Unfortunately, however, 20% of X, which would be $200, I'm soaking up the cost of that. I don't get to sell it, so my net gain is only going to be $800 just on those goods. Now, this is just an example to kind of give us thinking a little bit more quantitatively. Now, when we subtract or we move things over, we are going to get this. Realistically, we only make 80%, or we only make an income that's 80% of our total goods output. But you can see that whenever you move this X over here or you move this X over here, you'll end up with a 0.8. Services, same kind of idea. Well, my total potential income is Y dollars of output, but I'm buying some of the goods, so my expenditures are, well, there are X dollars of total goods output, and I am going to purchase 80% of that. And similarly, I am not selling all my services, so I'm keeping some of them, so I'm going to have to soak up that cost. So that's going to be an expenditure to me, and that's going to be 30% of Y. Great. Well, now I have a system of two equations and two unknowns, and I can find the solution, or hopefully there is a solution. So I'm going to do some rearranging here. So 1x, or x equals 0.7y plus 0.2x. I can move, I have to get the variables on one side in order to execute the Gaussian elimination. And when I do that, I get 0 equals, and I'll just 0.2 minus 1 is negative 0.8x. Move that x term first, plus 0.7y. I'm going to do a similar thing for services. For services, the equation is y equals 0.8x plus 0.3y. And so if I subtract that y over, combine like terms, I get 0 equals 0.8x minus 0.7y. Okay, that doesn't matter which equation I start with first, but I'm going to form my matrix. I have, for let's say goods, which is this equation here, I'm going to have x, y constants, and my coefficients for x and y are 0.8, negative 0.7, and 0. And here they are negative 0.8, 0.7, and 0. Okay, now if I do the reduced row echelon form of this, the final step, reduced row echelon form, if I define this to be matrix A, then I end up with 1, negative 0.875, and 0. And 0. And then the second row, what happens is it zeroes out completely. Now, not to fear, this is not a false statement in this row. This implies what? This implies that 0x plus 0y must equal 0. Well, that if this constraint alone means x and y can be any number, because 0 times any quantity plus 0 times any quantity is always 0, no matter what the values of x and y are. So it just turns out that that second row is pretty useless in telling us the solution. Now, this first row reads that 1x minus 0.87y must equal 0. Put a little must above there. All right, well, now I have something that tells me how x and y must be related. Now, what I didn't get, unfortunately, is a single solution. This is one of those situations where we are going to have infinitely many solutions. Now, how do you find at least one of those solutions? To find one of the solutions, I just have to make sure that whatever I pick for x and whatever I pick for y, that x minus 0.87y equals 0. Another way to think about that is that if I write it this way, x must equal 0.875y. Now, because the first row has a pivot, has its first non-zero number is in the x1 column, that means, or sorry, the x column, that means that y, the other variable, the second row doesn't have any leading non-zero values. The whole row is 0. So that means that because x is in the first row, the x coefficient is the first leading non-zero number, that's going to imply that y, we're going to make y a free variable. Y is a free variable. Now, you could have made x a free variable as well, but if you follow this kind of rule of thumb that you look at each row, and the non-free variables are the ones that have columns in which that value represents the first non-zero value, then it'll make things easier a little bit down the line. So in other words, to kind of summarize this, you can say that, write this down, as long as x, the dollar value of total goods, equals 0.875 times y, the dollar value of total services, we have a solution. Okay, so if I look at this equation now and I say x equals 0.875y, and y is free, that means any ordered pair of the form x, y, well, as long as x is 0.875 times y, and this can be anything, I can find infinitely many ordered pairs. Let's think of one that will work. Well, let's say choose y equals 100, or 1,000, excuse me. If y produces, or if there are $1,000 in services, then that means that x would have to be 0.875 times y, which is equal to 0.875 times 1,000, which is equal to 875. So that means that I can produce $1,000 worth of services, and as long as correspondingly the goods sector produces $875 worth of goods, then we will have an equilibrium situation where each company's incomes equal their expenditures. Again, many possible solutions here. It really just depends on their manufacturing level. So suppose that, let's say we find out that y equals, I don't know, 1 million is the optimal amount. That's really how much how many services are produced in a given year. Well, no problem. If we want to be in an equilibrium environment, then x just has to equal 0.875 times a million, which equals $875,000. So as long as I produce $1 million worth of services, I should produce $875,000 worth of goods. That way my income equals my expenditures, and there's a complete break-even point. That is really what it boils down to. Another way of thinking about this is 87.5%. All right, because if we multiply by 0.875, we're really taking 87.5% of the y value to get the x value. So basically, another way of looking at it is that the goods sector has to produce 12.5% fewer output dollars than does the services sector. So there's got to be a higher dollar amount in the services sector, and an 87.5% of that dollar amount is how much the goods services sector produces. So hopefully this has been helpful, and thanks for watching.